Alright guys, hello. Can you see the stream? Uh Hang on, let me go plug this in mods first and then we'll start. Um Suboptimal Playz stream. Alright, wait, we'll get a start on then. I mean we'll get started. Um yeah, so I guess it's just we just start the paper. I mean like this is 2022 Scholarship Calculus. Yeah, so it is what it is. Yeah, I guess I'll just like gotta get the extra performance on the calculator before we start. So yeah, I'll start the stopwatch and then we can just start doing the paper. I mean, might as well. Alright, so if z is a complex number. Oh, far out. Wait, hang on. My tablet's acting a bit sus. Alright, 1a. If z is a Oh yeah, so I read the comments after every question so I don't get like distracted or anything. But yeah, I do read chat at some point. Alright, so 1a. Fuck is this? Z plus a equals square root a z plus 1, where a is positive real number, a is not equal to 1. Find the value of I see. Okay. So this one you just bash, right? So let z equals x plus iy. Um, I mean, this is probably not like the most optimal way to do it, but like, we are suboptimal Playz after all. So you just expand this, right? You just expand. Um, what do you do here? Oh no, there should be an a here as well. And then so the two ax's cancel. Um, yeah, so you just live like a squared minus 1, a squared minus a equals a minus 1 x squared plus y squared. I feel like that's not right, but it is what it is. So z is square root of a minus 1, I think. So yeah, you just bash it. Um, yeah, so. Oh yeah, terminus. I don't really do Ollie that much anymore, but I mean, I still do like comps like SMMC and stuff, but I don't like actually practice very much. Alright, so wait, did I get it wrong? Wait, wait, it's good, eh? Oh, facts. What the fuck? Ah, there we go. X plus y equals pi on 4 tan x. Um, wait. Because this is like what, 90 degrees, right? Or is this 45 degrees? Pi on 4 is 45 degrees. Yeah, 45 degrees. So you're really sort of saying like instead of in radians, but into so you're saying like tan of x plus tan of pi on 4 minus x, and you want to set that equal to 1. Okay, so it looks like the solutions are always like 0.7-ish, and then, well, obviously it repeats. It repeats after pi, yeah. Yeah, it's always like 0 and then 0.78-ish. So, okay, so that gives us a start. So we're looking for yeah, so we're looking for tan x plus tan of pi on 4 minus x equals to 1. Oh, right, so you go like tan x. Do they give you the trig identities in Skull? Let me just check the Skull formula sheet real quick. Okay, they do. So okay, so tan. So this is minus, right? So we want tan pi on 4 minus tan x over 1 plus tan pi on 4 tan x equals 1. I guess. So now you just have everything in terms of tan x, right? So like you can just solve that easy. Also, the tan pi on 4 is 1, I'm pretty sure. Let me just check. Tan pi on 4. Yeah, that's just 1. Okay, so that just dips. Cool. So yeah, so tan x 1 plus tan x minus tan x equals 1 plus tan x. Wait, this is kind of weird. Whatever, let's just keep going. So tan squared x minus tan x plus 1 equals 0. That doesn't seem right. Cause remember, like x equals 0 should be a solution, right? So somewhere along here we've made a mistake. Because wait, so like if I plug in 0 right here, like it doesn't work. So we must have gone wrong somewhere. Oh, I forgot 1 minus. Fuck me. There we go. Okay, so right. So okay, so yeah, that makes more sense now. Okay, so tan x equals 0 or 1. X equals in pi or in pi plus pi on 4. Yep, that's good. Wait, and then pi on 4. Yeah, that matches what the graph gave us. So that should be right. Alright, let's move on to question C. Oh, what is this for 1C? X to the 4th plus x cubed minus 4x squared plus x plus 1 equals 0, and x is less than 0. Okay, so x to the 4th plus x cubed, x cubed minus 4x squared plus x plus 1. Okay, so x is like... X is either like negative 2.6 or... Okay, so that's like golden ratio minus 1. Negative golden ratio minus 1. And then this is like... Okay, so they're both like negative 1 plus or minus golden ratio. Sort of. Which is nice, which is nice. Okay. I don't know, I think they want you to find x cubed plus 1 on x cubed just like directly though. I mean the first thing you should do always is you just go like minus plus 1 on x plus 1 on x squared equals 4, and then now it's symmetric, right? It's interesting though because it's not clear how to proceed from here. Oh, well yeah, I mean okay, you solve for x and y, yeah. I mean, that's like pretty much it, right? Oh, wow. Technically negative, I think. Negative n pi. Yeah, there we go. Hmm. I don't know though. Like, can you just straight up solve this equation? Okay, I see. I see. Okay, so this indicates, right? I don't like this. This indicates that Okay, so because the calculator tells you that, you know, 1 is a root twice, right? You know that x plus 1, no, x minus 1 squared divides the polynomial. And then you just do like polynomial long division, right? 4x squared plus, because since x equals 1 is a double root by inspection, um how does this work? So you get x squared right. So you get blah equals x squared minus, so x minus 1 squared times you get x squared minus 3x plus 1. And then I guess from here, right, because you know that x squared minus 3x plus 1 equals 0, then you know that x plus 1 on x equals 3, I think. And then now you just need to expand this, and you get x cubed plus 3x plus 3 on x plus 1 on x cubed, which is equal to 3 cubed. So x cubed plus 1 on x cubed equals to 3 cubed minus 3 times 3, which is 18, I think. Okay, so yeah, so let's check this. I mean, negative 2.618. So negative 2.618 to the power 3 plus 1 on negative 2.618 to the power 3. That's negative 18. I don't. Where did we mess up here? Oh, this should be a plus as well, right? And then this is plus. Right, it's like always check your work, right? Because you might have messed up somewhere. Alright, let's go. Okay, so that was the first question. Just take a lap. How does this work? Alright, there we go. Okay, so x squared minus 4x plus 10 equals k, x plus 1 squared. K is real. Oh, easy enough. Okay, so for this one, you just expand it, and then you take the discriminant with the same sign. Whatever. We'll get to that part later. Okay, so I guess the same sign part is like the easiest. So if we take x minus alpha, x minus beta, say the two roots are alpha, beta, x squared minus alpha plus beta, x plus alpha beta. If alpha, beta are the same sign, then alpha, beta is greater than 0. So so either either k minus 1 is greater than 0 and k minus 10 is greater than 0, which implies that k is greater than 10, or k minus 1 is less than 0 and k minus 10 is also less than 0, which implies that k is less than 1. Okay, so let's get the two distinct real roots part. So the discriminant is b squared minus 4ac, which is 2k plus 4 squared minus 4 times k minus 1, k minus 10, which has to be strictly greater than 0 for it to have two real roots. So yeah, so we just go 4k squared plus 16k plus 16 minus 4k squared. How do you 11k plus 10? And stuff seems to cancel, which is nice, I guess. So this cancels with this, and then so you get 60k minus 24 is greater than 0. So 60k and 24k is greater than 0.4. So either 0.4 less than k less than 1, or k greater than 10. Alright, I think I got that. Alright, 2b. Consider the triangle ABC shown. Okay. Find the exact area of this triangle. Right. Geo problem. Okay, so this is like 16 over sine 2 alpha is equal to 12 over sine alpha, right? And so, I mean sine 2 alpha is equal to 2 sine alpha cos alpha. So we'll just say like 2 sine alpha cos alpha over 16 is equal to sine alpha over 12. Gotta be real careful, like I don't mess up anything. So cos alpha equals 16 times 16 over 12 times 2, which is 2/3. Okay, so now it asks you to find the exact area of the triangle. Okay, so how do we want to do this? So the way we do this is like oh, you want to find the area of ABC, right? So you use like okay, so we have sine alpha though. So sine alpha is root 1 minus 2 on 3 squared, which is root 5 over 9, right? Okay. Okay, so sine of cause if I look at this angle here, right, that's 180 minus 3 alpha. So sine of 180 minus 3 alpha equals sine of 3 alpha, because that's how sine works, right? Yep. I guess I should be putting degrees technically, but whatever. What's the okay? So let's look up the formula sheet, right? So sine A cos B, so sine 2 alpha cos alpha. Like, I know there's like a proper way of doing it, but I just can't be bothered. Like I'll just rederive it. Plus cos 2 alpha sine alpha. Cos squared is 1 minus sine squared, right? So that's like 3. No, I think I messed up somewhere. This should be. Oh no, maybe. Yeah. Okay, so this is. Oh wait, and this should be 3, not 9. Far out. Okay, so then that's 3. So that's 3, and then this is just root 5 minus 4 times root 5 on 3 cubed. Okay, cool. And if we go down here, oh, don't want to expand that, so that's 4 times 5 on 3 cubed times root 5. Well, that's a bit sus though, right? Like, cause and that should be 3 cubed, right? So it's actually 27. Okay, so that should be wait, far out. Wait. Oh. Okay, there we go. So that's 7 root 5 on 27. Right, now we go back. And so we go A equals a half AB cosine C. And that is 224 root 5 over 9. Cool. Consider a different triangle. Whose side lengths form a geometric sequence with a common ratio of r. Okay. Okay, so we got like 1 r and r squared, and this is alpha. We'll log the shortest side is 1. Let the ratio be r. Okay. Okay. What are we doing here? So what does this mean? Like okay, so you can okay, you could use cosine rule, I guess. So what's it like? R squared equals r squared plus 1 squared minus 2 times 1 times r squared cosine alpha. This easy. This is like maximum A. Maximum alpha is lowest cosine of alpha, right? So highest R. And then so obviously by triangle inequality, r squared has to be less than r plus 1. I don't know how this works though, cause like if you consider like the like I just don't think this works. Like because if you consider the largest r that you can have, then it's gonna be like a really thin triangle, right? So r squared equals. Oh, right. Okay, so this has to be r4 plus 1. Okay, wait. So that changes it then, because then it's no longer. So r squared equals r4 minus 1 plus 1 minus 2 times r squared cos. Okay, that looks better. So, okay, so 2 cos alpha r to the 4 equals 1 on r squared minus 1. Okay. So, yeah, so we're just trying to, so now we're try to minimize r. No, try to minimize cos of alpha. And then so, yeah, okay, so r, right, so so it's, if it's r squared plus 1 over r squared, then it's greater than or equal to 2 square root of r squared times 1 over r squared by AMGM, which is equal to 2, so cos alpha is greater than or equal to a half, alpha is less than or equal to pi on 3. So that, wait, so r, so the equality case is r equals 1, alpha equals pi on 3, which is the equilateral triangle. I guess that makes sense though, yeah, cause if you think about it as r, cause if you have like a 1 r squared triangle, then that angle is gonna be real small. So yeah, I guess that makes sense, yeah. So it's equilateral. Alright, question 3. Yeah, SpeedDVs, I messed up a lot, but I think I got it in the end. Alright, 3a. F of x equals 5x over e to the square x plus 1. Huh, okay. Do you not just quotient rule this? Like, f prime of x equals using quotient rule. So it's like you yeet the first, keep the second, minus you keep the first, and then you yeet the second. Over the first, was it the second? The second squared, I think. Wait, is this? Alright, so yeah, I guess you just, if you sub in 0, sub x equals 0. 5 root 1 minus 1 times 1 times a half over e to the 1. Nah, I don't know. I mean, I don't let's just check that the answer's correct, right? So if we go calc d by dx and then we just put in the function fraction e to 5x times square root of x plus 1 over e to the square root of x plus 1 at x equals 0, 9 on 2e. No, wait, we fucked up somewhere. Okay, where did we fuck up? Is it 10 on 2e? Oh, it is. Wait. Okay, where's the... Okay, so evidently this 1/2 is not supposed to be there. But why is it not supposed to be there? Oh, on God, bro. Wait, is the calculator tripping though? Like, nah, I mean, put in everything correctly, so it should come out correct as well. So okay, so 5e to 5x, yeah, we got that, and then you just keep the square root. I don't get it, man. Like, okay, wait, so x plus 1 to the half goes to a half. X plus 1 to the negative a half times 1. Alright, so this should be negative r, but it still doesn't change the fact that, like, because when you sub in 0, does it not still just become 1? And then the e to the 5x also becomes 1 when you sub in 0? Like, or is there meant to be like an x that comes out somewhere and then... oh God. Maybe the calculator is tripping. Okay, what if I just put in 5 times e to the 0 times square root of 0 plus 1 minus e to the 0 times 0 plus 1 to the power of negative a half times the half over 1. And yeah, it just tells you 9 on 2, bro. What the fuck? Wait, but when you actually get the calculator to do the differentiation, it comes up with 10 on 2, which is 5. So why is the second term not meant to be there at x equals 0? Wait, is quotient rule? Is quotient rule in the text? F times g dash over g. Oh, wait, no, I'm actually stupid. Oh, no, because you have to... Oh, facts. You have to use quotient, because the quotient rule is you differentiate the bottom, not the second one. Okay, so... Okay, maybe the hint actually is useful then. Far out. Okay, so... Let's just start from the beginning. Okay, so... D on D... Okay. Actually, no, I don't need the hint. Let's just do it normally with quotient rule. So if prime of x using quotient plus product rule equals. Okay, so the bottom part's good. So it's e to the power x plus 1. But when you apply quotient rule, it has to be e squared of x plus 1. And then you need to apply product rule to the inside bit. So it's e to the 5x. No, it's 5 e to the 5x square root of x plus 1 plus e to the 5x times x plus 1 to the power negative a half times a half. Right, and then you do the thing. So 5e to 5x square x plus 1 times. Oh, and then you have to apply like chain rule or something. Like minus. So you keep the e to the 5x square root x plus 1, and then you multiply by g prime, which is the square root of this. So okay, so so you get, okay, so obviously you get e to the power of square root x plus 1, because that doesn't change, times, but then you have to differentiate that, so you get x plus 1 to the negative a half times 1 on 2 on e to the x plus 1. Okay, and then when you evaluate this at, you should get 1 on e. What's this? E to the 1. Wait, it doesn't seem right, because why? Because that implies that the e's at the top and the bottom cancel. Bro, I must be tripping. Like g times. Maybe we will use the hint. What does the hint even want you to do? It just says take the so okay, so f of x, so ln f of x equals f prime of x over f of x. Right. Oh, and then you take the derivative of that. Okay, so ln f of x. What's ln f of x? That's just ln of e to the 5x square root x plus 1 minus ln of e to the square root x plus 1, which is just so yeah, at the end of the day, you still have to take the derivative of ln of square root of x plus 1 though. Maybe it's not that bad, but oh wait, actually no, you just use the hint. Wait, that's actually big brain. Okay, so there's just ln of e to the 5x plus ln of minus ln, which is just 5x minus root x minus 1. Okay, plus. So take the derivative of that. What do you get? You get 5 minus x plus 1 negative a half times a half plus. Right, and then you have x plus 1 negative a half times a half, but then you have over x plus 1 a half. And so this evaluated at x equals 0 gives you 5 minus 1 times a half plus a half, which is 5. Okay. Which is supposedly f prime at 0 over f at 0. So if prime at 0 is equal to 5 if at 0, which is 5 times 1 times 1 over e. Okay, that's 5 over e. Okay, so that's what we got. Okay, so maybe the hint was useful after all. Maybe the hint was useful after all. Okay, cool. That's 3v. Yeah, I don't know. I didn't like the hint, but I think the hint actually was useful. So I don't know. Maybe the hint was useful. Okay, 3v. Let's. So so what's the ratio between the rate of change and depth of the drips from the dripper into a flask? At a constant rate. Okay, so okay. Oh wait, what? So okay, so this is so confusing. So are they just asking like okay, so this is like 18, right? And this is like 18. So if the dripper is like T, then this radius will be like the dripper is like H, then this radius will be H on 2. And then so V equals a third pi r squared H or something. So a third pi H cubed on 4. 12. Okay, so V drip. And then we're told okay, so this is like one of those like chain rule questions, right? So it's like dv drip over dt is equal to dv drip over dh times dh over dt. So like 50 equals pi h squared on 4 times dh on dt, which is equal to pi times 81 on 4 times dh on dt. So dh on dt is like 200 over 81 pi. Okay. This is like the height of the dripper, I guess. Okay, and then we look at the flask. Right, so the flask is just a cylinder, right? So it doesn't actually matter what height it is. So dv flask on okay, so v flask. Right, so v flask is equal to pi r squared h flask, which is equal to 81 pi h flask. So dv flask on dt I guess this is technically negative 50 as well. So I mean like whatever, but like technically, so this one's positive 50 because it's actually filling up. dv flask over dh flask times dh flask over dt, which is so 50 equals 81 pi times dh flask on dt. Seems legit. So dh flask on dt is equal to 50 over 81 pi. So the ratio is 50 on 81 pi divided by negative 200 on 81 pi, which is equal to negative 104. Alright. Okay, yeah, so for Skull, I think you just like get experience doing maths, like especially if you do like further maths or like 199 kind of thing, then it helps with Skull. And yeah. Alright, so 3C. So if we got A, B, C. Okay, so this one is like we should move it up. So BAC is 90 degrees. E lies on AC. And G lies on the arc BC. Oh, I see. This is a nice problem. Okay, so yeah, so I guess the idea with this one is like you can sort of like you can do this synthetically, I guess. Yes, okay, so say BC is the x-axis. Since if G has a fixed angle to the x-axis, then the distance if G depends only on the distance between G and line BC. Hence, this distance will be largest when G is furthest from BC. Note that angle EFC, the angle ABC, 45 degrees always because of parallel lines. Right, so if we drop like this perpendicular from G down to like H or something, then I guess the thing is like this is R, and then so this is 45. This is 45 degrees as well. So this one is R on root 2. So this one will be R minus R over root 2, right? So then if G equals root 2 times R minus R on root 2, which is just like root 2 minus 1 times R. So the maximum of if G is R times root 2 minus 1. Cool. And yeah, okay, so yeah, so that's Q3 done, so we can like split the time. I think the later questions are harder, that's why it's like taking me more time, but I don't know, maybe I'm just huffing copium. Yeah. Ah, yes, the classic complex number trig identity problem. Ah, okay, so I don't need the identities, man. Like this thing, you just bash, right? So cos. Wait, do you bash? No. Yes, you just bash, right? Cause you go cos of 6 theta equals. Yes. You just go cos of 6 theta equals um cos of theta. Actually, maybe no. Maybe you don't want to bash this one. Maybe you don't want to bash this one. I think they made it 6, so it's like real hard to bash. Uh, okay. How does this work then? Cause you have to use you have to use like the thing, right? So like cos theta equals cos of 6 theta equals e to the 6 I theta plus e to negative 6 I theta over 2, right? Okay, so yeah, you got that. Oh wait, no, I'm tripping, right? Yeah, you just go like cos to the 6 of theta equals e to the I theta plus e to the negative I theta on 2 to the power 6. Bro, and then you just go, it's 1 over 64, right? And then you just do binomial expansion. E to the 6 I theta. Oh, yeah. Also, wait, my calculator DC'd. How does this work? Okay, so projector. There we go. Calculator should be back. So we just go like, how does this work? So stat. No, it's prop. Yeah, so 6C1. Okay, oh, okay. Obviously that's 6. Um, plus 6 e to the 4I theta plus 6C2. Yeah, so that's 15. 15 e to the 2I theta, and then 6C3. That's 20 plus 15 to the e to the negative 2I theta plus 6 e to the negative 4I theta plus e to the negative 6I theta. Alright, easy dubs. And then you just expand it, right? So that's like, you can group the terms, right? So you just group the terms. Oops. And then we go down here and then. Wait, how did they get 1 on 32? It should be 1 on 64. Oh wait, no, because this is 1/6. Right. Okay, so yeah, wait. So it's you just make it plus 3 on 16 cos 4 theta plus 15 on 32 cos 2 theta plus 5 on 16 as required. And you gotta leave a little box at the end just to make sure they know you proved it. Okay, 4B. Um, yeah, I'm uni now. And yeah, I mean you can use triple and double angle, but yeah, I don't know. I just I mean they give you the hint, you might as well use it, right? Like what was that dumb one? Like the differentiation one where I didn't use the hint and then I just suffered. So yeah, I would just use the hint. Alright. By evaluating what? You evaluate the integral from 1 to 0 y dx. What the fuck? No, there has. No way, no way. X equals cos cubed of t, y equals sine cubed of t, 0 less than equal to t less than equal to 2 pi, right? Okay. What? Hey, no way. There must be a better way, right? Like, what? Are you just meant to go like t equals arc cos of. Wait, actually, wait, no. This might actually work. T equals arc cos of cube root of x. Alright, and then y equals sine of arc cos cube root of x cubed. And then like what is sine of arc cos, right? That's just like it is a theta 1. No, this is stupid, but and then they want you to integrate this from 0 to 1. I don't know, man. Kind of sus. Hmm. I don't know. I'm like shit at integration, so. Alright, can you do this like integral by parts? Wait, so you go. So this is like 1 minus x 2 on 3 times 1 minus x 2 on 3 to the power of a half, right? So this one's your if, this one's your g. Oh no, that suffers from the same issue, doesn't it? Because you still end up having to integrate. Wait, no, I'm stupid. No. This one, wait. No, this one's your g, and then this one's your if prime. Does that work? Bro, if only this was like cos squared t instead of like cos cubed t or something. Oh. How does this even work? Like, okay, so parametric, so cos x cubed sin x cubed, and then trig, I guess. Suspicious. Okay. Like there's no way this works. There's no way this works. Like this is. I don't know. What is the answer anyway? Like 1 minus x to the power of 2 on 3 to the power of 3 on 2. That that's not good. That's not good. Okay, so it's just some random number. Okay. So they want you to calculate the exact area. Ex exact area of the asteroid. Bro, why is this? How's wait? Is there a U sub in the? There's no U sub in. Amazing. How does U sub even work though? Like, cause you go like x equals cos cube t, y equals sine cube t, and then it's like what dx dt equals 3 cos squared t times negative sine t. Is this how U sub works? Like you go 1 to 0, y dx equals 1 to 0 of y times 3 cos squared t negative sine t dt. Wait, but then you have to change the thing from like I don't know 0 to like pi on 2, I guess, because 2 pi on 4 is pi on 2. Okay, okay, so that's how U sub works. Um, I could be tripping. Like, wait, no, I want negative 3 integral. Bro, how's negative 3? Do you not just sub like? Oh, it was this thing. It was this thing. You use this one, right? Cause you're given. Wait, but you have to do it for sine instead, right? Basically, instead of doing it for cos, you do it for sine instead. So negative 3 pi on 2 0 sine 4t 1 minus sine squared t dt. Um, No, cause you got like sine 6t. Surely is literally the same as 4a. Yeah, I can't be asked. Let's do it the same as 4a. -3. It should be 2. Right, and okay, so we just need to do, cause we know that cos squared t by like double angle is equal to cos 2t plus 1 on 2, right? So cos 4t, and then we just need to use these identities. Yes. So it becomes 1 on 8, I think. 1 on 8, and then it'll be cos 4t. And then so instead of 6c1, it would be 4c1. So it's a half plus, then 4c2 would be 6. That doesn't seem right, but let's just see how it goes. Cos 4x plus 4 cos 2x plus 6 cos x to the 4th. Nah, something's off. Oh, it's cause this one doesn't have a doubling, so this one should only be 3. And then now it should be fine. There we go. Okay, and then cos the 6th of t is equal to 1/32 cos 6t plus 3/16 cos 4t. Cool. And then so this area, if we collect all the terms, is equal to -3 integral from pi on 2 to 0 of, so you have 1. Okay, so we have one of these, right? So we have 1 cos squared, so we need a half. And then minus 2 times 3/8 plus 5/16. 5/16. It's 1/16 apparently. Okay, so 1/16. Okay, so how many cos 2t's do we need? So we need a half minus 2 times a half plus 15 on 34 apparently. 32. So that's minus 1/32 cos 2t. Yes, and then how many cos 4t's do we need? We need -2 times an eighth plus 3/16. So that's -1/16. And then we only need a 32nd cos 6t. Wait, and then this should be like, cause like if you look at cos, right? Cos x. Shouldn't these all be like cause this one's let's integrate to there, is 1, right? So this one is pi on 32 minus 1 on 32. But if we look at, even if we look at cos 2t, then the integral should be 0, right? Cause yeah, so all the higher ones should be 0 as well. So it should just be negative 3 times pi on 32, which is I'm gonna call that close enough to the numerical results of this. Yeah, that agrees to like 7 decimal places. The only sus thing is the negative though. I don't know where we fucked up here. X equals cos cube t, y equals sine cube t. So when we did the substitution, I guess that's like one thing to check. So right, cause this 1 is gonna be when cause cos of 0 is 1, and then cos of pi on 2 is 0, right? So it should actually be the other way around. So alright, that's good enough for me. Alright, let's go on to C. Wait, and then let's. Oh yeah, so you have to diff x and y in terms of t, yeah. And then yeah, it just works out. So alright, well on to 4C, I guess. Apparently people say this one is hard. Um, let's see what it is. Okay, so okay, so you got the ellipse where you got your foci. You got your point. Right, and then you have this theta. Well, I mean, one way to do it is you just bash you just bash sine rule, right? You just go through and then but I don't know. I think there's a bit of a sussy way to do it. Um okay, so I guess I don't know, man, like this is kind of sus. So this is B, right? And then yeah, so the total height is B. Damn, I do not remember anything about conics. Let's see, would the oh, there we go. Okay, so B squared equals A squared minus C squared, apparently, according to the formula sheet. So that's nice to know. So that means like c squared equals a squared minus b squared. Hmm. I don't know how to do it. This one seems hard. Like not gonna lie, like it either seems like a lot of bashing, or like there's some sense solution that I'm missing. Like, cause you have your negative c and you have your positive c, and then you got your x naught y naught. And well we know that like x naught on a squared plus y naught squared on b squared equals 1, right? But like, I wanna understand like what this like tan theta on 2 means. Like, cause actually, how do we even calculate theta? Cause theta. hmm, Okay, so this is gonna be 2c, right? And we can call this one like d1. We can call this one like d2. So cos of theta equals d1 squared plus d2 squared minus 2d1 d2 over no minus 2c squared over 2d1 d2, right? And then but that gives you like theta, right? Not theta on 2, so it's kind of weird. Cause later you get like area equals half d1 d2 sine theta, right? I can sort of see, because that kind of cancels out, right? But so you get like d1 d2 equals d1 squared plus d2 squared minus 2c squared over 2 cos theta, right? So area is a quarter tan theta times d1 squared plus d2 squared minus 2c squared. And then now we just need to prove what's the double angle formula for. No, I don't think this helps though, because it's like, cause what do you get? You get like a half tan theta on 2. 1 minus tan squared theta on 2. And then you just have to hope, you just have to hope that like these cancel and then become b squared, 2b squared, or something like that. I mean, I buy it, but fuck it. Let's just do it. Okay, so d1 squared is equal to x naught plus c squared plus y naught squared, right? Which is, yeah. So okay, so these two cancel. So d1 squared plus d2 squared minus, that'll be 4c squared, I guess. It's equal to x naught 2x naught squared plus y naught squared minus 2c squared. Okay, that's not good. I mean, how are you meant? Well, and this is like supposedly equal to 2b squared times 1 minus tan squared theta on 2. I feel like you have to use this the ellipse equation at some point, and since we haven't used that, it's like kind of sus. But at the same time, I don't see how to use it without. Sufficient to prove. Maybe I'll do. Uh, oh no. No, these cushions don't look nice either. Oh no. Oh no, that's not good. Maybe I will keep doing 4C. Far out. How do you do this? Like, Like maybe I will do the strat where like, cause cause the area cause the area equals 2c squared, 2c times the height. No, it equals c times the height. Right, so, and then c, so, which is supposedly equal to b squared tan theta on 2. Like, I don't know, man, like, wait, but the height is just y naught, right? So, cy naught is supposedly equal to b squared tan theta on 2. So, see, we'll see. Can you just like, can you just like prove this directly? Like, cause what you have like bx naught squared on is equal to plus y naught squared is equal to b squared. No, but you don't know this angle though. The only way you know this angle is through this. Cause how do you get the tan of that angle? You need to get the sine of that angle over the cos of that angle, right? And then like, actually, what if we just bash this like, because you have cos there, and you have an expression for d1 and d2 in terms of x naught and y naught, but it should be c minus x naught, right? Surely. Okay, and then so. I don't know, there's just like symmetry going on, but I don't know how to use it. Like it's so weird. Especially like, I don't know how you turn it into like tan. Oh, what the fuck is this question, man? Like, show that the area of triangle F1 P F2 is equal to B squared. So this is the question. What the fuck? Okay. Alright, fuck it. Let's. But I literally don't see any other way. So this is theta. C minus x naught. C squared minus x naught squared. We just multiply through. I swear this is where we were at before though, like. I don't even know how this helps though. See, that's the thing, right? Like, cause. Wait a minute. This on the right side we have y naught, right? So we have y naught. Remember the expression for area is cy naught, right? No, that's stupid. No, that's stupid. No cap, bro. What is this? It just becomes like no, because you have to multiply. I just don't get how do you relate y naught, x naught, and tan? Especially like tan of theta on 2, not just like tan of theta, cause like tan of theta on 2. Yeah, no, it's real weird, right? Cause it's like tan of theta is equal to 2 tan theta on 2 or minus tan squared. But you can't get tan of theta on 2 just like out from that nicely, right? Cause you get it's like a quadratic, right? So there's no like nice solution. So you have to do it in terms of tan of theta on 2. Unless you had it in terms of sine already. Like how did that work? Cause sine theta on 2 cos theta on 2 over cos squared theta on 2. Cause that would be valid, right? And then that will give you your tan theta on 2. See you somehow see, and then this is sine theta, right? And then this is 1 minus sine squared theta on 2, which is like stupid. No. Yeah, but that's actually also wait, cos squared. It's 1 plus cos squared is 2 cos theta plus 1 on 2. So somehow you need to make 2 sine theta over 1 plus cos theta. And then that just becomes tan of theta on 2 just becomes that. Like how does that work? Like huh? Like I'm supposed to get 2b squared sine theta over 1 plus cos theta. And that's supposed to be your area. I mean, I guess I can actually I guess I can sort of see how it works cause this sine comes from area, like the trig bash. So you just have to prove that 2b squared on 1 plus cos theta is somehow equal to a half d1 d2. Oh yeah, that actually seems doable though. That actually seems doable because remember here like a half d1 d2. It actually comes from cos theta, right? So I don't know, maybe it just cancels out because 2b squared. Maybe it does all just cancel out. I don't know. Like am I tripping? Like wait, no, this one's still a half, right? Cause wait, no, it isn't. It's wait, what? 2 cos squared a. Wait, I swear I'm getting close though because it's like Wait. Well, because you know b squared is equal to a squared minus c squared, right? Like, and then this supposedly gives like a half a squared because it's wait, because it's like a quarter d1 plus d2 squared, which is a quarter um quarter a squared. No, because it is a squared because this one is 2a. So but why is this 2, right? Like, it doesn't make sense. Like, how come? No, fuck off somewhere, like, cause whatever. Close enough. Close enough. I'll come back to it later. All right. 5a. Okay, so what the fuck is this? You want to integrate from a to 0, tan 1, tan 2, tan 89 dx. Wait, but isn't this just tan 1 like up to tan 89 times a? Like, is they want you integrate? Maybe you want because it says product. This is like stolen from somewhere. I swear I've seen this on like mods before. Something like that. Something dumb like that. Like, I swear there was like something very similar to this. Cause it's like cause yeah, like tan of x. Wait, no, this is the stupidest thing, right? Cause wait, hang on. Cause like tan of isn't tan of 1 times tan of 89 just like 1? Bro. Wait, so tan of x times tan of 90 minus x equals 1 for all x. Therefore, tan of 1 times tan. Bro. Alright, this is like. Tan of 44 times tan of 46. Okay, so tan of 45 is like. Is it 1 as well? Tan of 45? Oh, it is. Bro, wait. NZQA is trolling you. So, so the integral is just. It's just a. Oh, what the fuck? What? Bro, this is the sauciest question. 5b. Okay, so I'm pretty sure when they ask you to integrate something, instead of integrating, you just differentiate the other side, right? So let's see what we get. And then remember, they even tell you how to do this, right? Like, how is it? Yeah, they literally tell you how to do it. So differentiate the thing is equal to 1 plus the derivative of that. So that's 1 plus x squared, the minus a half times x times 2x, right? Because but then times a half over, and then that's wait, how does this work? Do we just huh? I don't get it. I don't get it. Wait, you just can you factor out the one of I see. And then yeah. Easy, right? Easy dubs. Alright. Um and then yeah. I guess on to the last question now. What is this? Okay, so okay, wait, let's see if I can crop it slightly better so that the question can actually be seen. Ah yes, there we go. And then we can yup. There we go. Okay, so when the difference in speeds will influence their path. Okay, so this is interesting. The path y equals f of x in the xy plane at 1. Then multiply. No, what differential equation? Oh no. F prime of 1 equals f of 1 equals 0. Okay, so oh, I see. Okay, right. Wait, no, I don't see. I don't see. Wait, is this one not just you take dy dx equals a, d squared y dx squared equals dA dx, and then x dA dx equals some constant lambda, um, square root 1 plus a squared. And then it's just a normal thing, right? Like 1 over 1 square root 1 plus a squared dA equals lambda on x dx, and then you use the thing, right? Use the thing. Natural log of 1 plus x squared. You integrate both sides. Plus x. And then you take e to the power of both sides, yeah, and then oh wait, no, this is a, right? This is a. Facts. Is is this what they want? Like I mean, wait, and then wait, this is scuffed because wait, Oh, I see. Okay, so A equals C1 x lambda C1 squared x to the power 2 lambda minus 1 over 2c1 x to the power lambda, which is a half c1 x lambda minus a half 1 over 2c1 x to negative lambda d. And then so y is the integral of a dx equal 1 over 2 lambda plus 1 c1 x to lambda plus 1 minus negative lambda plus 1, I think. And then, oh, of course, when, when assuming lambda, of course, isn't equal to 1, when lambda equals 1, a equals a half c1 x minus 1 over 2 c1 x, and then y equals a quarter c1 x squared minus and then of course plus c2 minus 1 over 2 c1 ln x plus c2, and then it should be all good, right? Because oh wait, no, you need the ICs, don't you? Wait, far out. I think you do the A. So you're given so you're given that A at 1 equals 0. So a half c1 minus 1 over 2 c1 is 0. Yup. And oh, that's nice. C1's just 1. Okay, so A equals a half x lambda minus x negative lambda. And then so y is just, you just integrate that, right? When lambda is not 1, and then so you get y of 1 equals a half and then when lambda equals 1, we have y equals a half x squared on 2 minus ln of x plus c2, and so y of 1 equals a half 1 on 2 plus c2 is 0, so c2 is negative a quarter. Alright, so I think that's good. Let's go back to question 4c, and then we'll try and finish it up. So we have that cos of theta is equal to d1 squared plus d2 squared minus 2c squared over 2 d1 d2, right? And then so that's from here, and then we use the sine from here. So sine of beta 1 well, no, I didn't even use sine, right? I just used cos only. So wait, so wait, so how do we do this? It was just I'm confused. Oh yeah, Jonathan, I am in uni, by the way. Yeah, that. Cause we were like area equals a half d1 d2 sine theta. Ah, but we have this, right? Cause wait, I don't even buy so 2 sine. So okay, fuck it. Lemma 1. Lemma 1. Tan theta on 2 equals 2 sine theta over 1 plus cos theta. All right, so so how do we prove this, right? You go you just go right hand side equals 2 sine theta over 1 plus cos theta, which is equal to 4 sine theta on 2 cos theta on 2 over, so remember 1 plus cos theta, because cos theta we can rewrite, right, as, so cos 2 theta is equal to 1 minus, is equal to 2 cos squared. So 1 plus 2 cos squared theta on 2 minus 1. Ah, right, so that's the issue. This 2 shouldn't be here. Okay, right, because if we just have this, then it's tan of theta on 2, which is the left hand side. So that's proven. So it suffices to show that area is equal to b squared sine theta over 1 plus cos theta. Right, and then so now, okay, so now we have lemma 2. Lemma 2. I want to say b squared over 1 plus cos theta is equal to this thing, right? Half d1 d2. And then so cos theta is equal to d1 squared plus d2 squared minus 2c squared over 2d1 d2, right? And then so so because 1 plus cos theta is not 0, 1 if and only if, we can take it over a half d1 d2 plus a half d1 d2 cos theta. Yes, it's all coming here now. So 1 half d1 d2 plus a half, no, a quarter d1 squared plus a quarter d2 squared minus c squared, which is equal to a quarter d1 plus d2 squared minus c squared, which is of course a quarter of 2a squared minus c squared, because d1 plus d2 equals 2a definition of ellipse, right? Which is equal to a squared minus c squared, which is true. Is true by formula sheet. And then applying the sine rule to triangle if, what was the triangle? If 1p f2, we obtain what do we obtain? Come on, we obtain area if 1p f2 is equal to a half d1 d2 sine theta, right? Because that's the sine rule, and then this is equal to b squared sine theta over 1 plus cos theta by lemma 2, which is then equal to, in itself, is then equal to b squared tan theta over 2 by lemma 1. And I believe this concludes concludes both the paper and both this question and the actual paper itself. I think I've done all the questions, so I will stop the timer. So 126 minutes. So that's actually better than last year, because last year I think I did it in like 2 hours 30. So yeah, I would say that's a pretty big W. Yeah, I mean, I guess thanks for staying around until the end. If you have any questions, then I'll be happy to answer. I don't know. Overall, I think Skull Calc this year was a bit easier than last year. I don't know. Yeah, definitely some of the questions, especially 4C was real hard this year. I think last year the hard question was like the last question. You know, every year they always give like some conic chord bash question that's like the hardest question. Because last year, actually wait, no, last year it was what do you call it? Last year it was that weird complex numbers one that was hard. But this year it's the ellipse one. But yeah, conics is always sus. So yeah, well I mean I hope you all did well in the exam today. Good luck with all your other exams, and I guess I'll see you in a year's time when I do the next stream. So yeah. I guess like, comment, and subscribe. I guess I have to say that, like, but yeah. Also, I should plug oh, whoops. I should plug Actually, no, fuck it. Thanks for coming. See ya.